Fusion power has long been seen as a potential solution to the world's growing energy needs. It has the potential to provide an almost unlimited source of clean and sustainable energy, without the environmental risks associated with traditional forms of energy. However, despite decades of research and development, it remains a technology that is still in the experimental stage. One of the key challenges in developing fusion power is the need to create conditions that are hot and dense enough to overcome the repulsive forces between atomic nuclei. This requires temperatures of tens of millions of degrees Celsius, which is much hotter than the core of the Sun. The only way to achieve these temperatures is by heating a plasma to the required temperatures and confining it using strong magnetic fields. The first experiments in fusion power began in the 1950s, and since then, scientists and engineers have been working to create a viable fusion reactor. The first successful fusion reactor was built in the 1980s, but it was not capable of producing more energy than it consumed. Since then, scientists and engineers have continued to refine the technology and improve the efficiency of fusion reactors. One of the most promising fusion experiments today is the International Thermonuclear Experimental Reactor, or ITER. ITER is a joint project between 35 countries, including the European Union, China, Russia, and the United States. The reactor is being built in Cadarache, France, and is expected to be operational by 2025. The ITER reactor is designed to produce 500 megawatts of power, which is enough to power about 500,000 homes. It uses a combination of magnetic fields and high temperatures to confine and heat a plasma, which is a gas-like state of matter that's made up of ions and free electrons. The plasma is confined inside a donut-shaped vessel called a tokamak, which is surrounded by magnetic coils. The key to producing fusion power is creating conditions that are hot and dense enough to overcome the repulsive forces between atomic nuclei. This requires temperatures of tens of millions of degrees Celsius, which is much hotter than the core of the Sun. In the ITER reactor, this is achieved by heating the plasma with powerful microwave beams and confining it with magnetic fields. The potential benefits of fusion power are numerous. Unlike traditional forms of energy like coal or gas, fusion power does not produce harmful greenhouse gases that contribute to climate change. It also produces very little radioactive waste, which is a major concern with traditional nuclear power. Additionally, the fuel for fusion power is abundant and readily available. It's primarily made up of isotopes of hydrogen, which can be extracted from water. Despite these promising benefits, there are still many challenges that need to be overcome before fusion power can become a reality. One of the biggest challenges is developing materials that can withstand the extreme temperatures and pressures inside a fusion reactor. Another challenge is finding ways to efficiently and reliably convert the energy produced by fusion reactions into usable electricity. Despite these challenges, many scientists and engineers are optimistic about the future of fusion power. With continued research and development, it's possible that fusion power could become a major source of clean, sustainable energy in the future. In addition to the ITER project, there are many other fusion experiments and projects underway around the world. These include the National Ignition Facility in the US, the Wendelstein 7X reactor in Germany, and the East Reactor in China. As we continue to explore the potential of fusion power, it's important to remember that no single source of energy will be able to meet our growing energy needs on its own. Instead, we'll need a mix of different energy sources, including renewable sources like solar and wind power, as well as traditional sources like natural gas and oil. By working together and investing in new technologies, we can create a cleaner, more sustainable energy future for ourselves and for future generations. The development of fusion power has the potential to revolutionize the energy industry and transform the way we generate electricity. Fusion power could provide a constant, reliable source of energy that's cleaner and more sustainable. Thanks for watching. Please like and subscribe.